Alright guys, here we go with lesson 103. And let me get on the right slide here. We're going to determine whether the sign of the product of three or more factors is positive or negative. So this will be actually kind of a nice little shortcut that we'll talk about with this lesson that I think will be useful to you in the coming days. We're going to raise a negative number to a power. We're going to divide terms by removing pairs of factors that equal 1. We're going to kind of factor out some of those algebraic expressions we've been using and use our canceling skills to simplify it. And we're going to use two methods to find the square root of a monomial. Now, you may not remember what a monomial is. We'll go over that again later in the lesson. First of all, we've got a whole series of numbers here that we are multiplying, and obviously we've got positive and negatives. Now, knowing the commutative property, we could organize them and put them in anywhere we want to. Right now, we're just going to work them from left to right, keeping in mind what the signs would be as you go. So if we have negative 3 times negative 4, that's positive 12. Positive 12 times positive 5 would be positive 60. 60 times negative 2 would be negative 120. And negative 120 times 3 would be negative 360. Notice that whenever we did two negatives, we came out to be a positive answer. And whenever we did signs that were different, like here, we had a positive times a positive, we ended up with a positive. The signs were the same. And then here, we had negative times a positive, and that ended up being a negative. So you keep those types of rules in mind, what we've already learned. Now let's take a look at this next chart here. And I want you to kind of study it and see if you can figure out a pattern to the sign of our answer for each of these products. And I kind of wrote a clue out here. So I'll give you just a few seconds here to ponder this. Alright. You notice that if there are an odd number of negative factors, that your answer is going to be negative. Okay, so let's see, every time you have odd. So here there was 1, here there were 3, and obviously here there were 5. Those would be negative answers. Now, if you have an even number of negative numbers, then your answer is going to be positive. Now, let's go back to our original problem here. And we had 1, 2, 3 negative numbers that we were multiplying. And we know that our answer did end up being negative. But we can know just from it being 3 that it's going to be negative. And then you can group them again however you want. You know, you could do 5 times 2 times 3, which is 30. 3 times 4 is 12. 12 times 30 would be 360. And we already figured out that it's negative. So actually that kind of speeded up our process a little bit. If we already know whether our answer is going to be positive or negative, we don't have to go then one at a time and keep track of what the sign is at the time. So let's take a look at this then. Here's our rule or a pattern that we've discovered. If the number of factors, negative factors, is even, the product is positive. If the number of negative factors is odd, the product is negative. So let's take a look at this one then. What do you think our answer would be? Well, we do have two negatives, which would make our answer positive. However, there's one little trick thrown in here, and that is the 0. If you multiply anything times 0, what's going to be your answer? Well, it's going to be 0. And of course, there isn't a positive or negative 0, so it's just simply 0. Alright, now this one doesn't have a little trick like that to it, so let's figure it out here. We have how many negative integers that we're multiplying? Well, it looks like 1, 2, 3. That's an odd number, so our answer is going to be negative. And then again, we can group them however we want. So here, let's see, we've got 5 times 2, which is 10, times 3 is 30. And here we've got 3 times 4, which is 12. 30 times 12 is negative 360. And it looks like, did I just do that one all over again, the same one? Nope, a little bit different. Okay. Just checking that I wasn't being redundant there. All right, now let's carry this a little bit further then. If we are taking negative numbers to a certain power then, I'm going to write this out, but we're going to talk about some rules here that maybe you won't have to write it out each time. Okay, I've got negative 2 times negative 2 times negative 2 times negative 2. Well, I have 1, 2, 3, 4 negatives. So we know that my answer is going to be positive. Then we simply do 2 times 2, 2 times 2, 4 times 4 is 16. Okay? These are supposed to be 4s. Now here, the same thing. You've got negative 2, negative 2, there's the third one, there's the fourth one, there's the fifth one. That means my answer is negative. Let's see, 2 times 2 times 2 is 8. Here's 4. 8 times 4 is 32, but it came out to be negative. Now again, let's think back to our original pattern. Hold on, let me undo that. We had said if the number of negative numbers was even, our answer would be positive, which it did come out to be. And we said if our negative numbers, if there were 5 of them, then our answer is negative, which proved out in that one also. Alright, now what I would like you to do is go ahead and go into your book on page 720, and why don't you practice those two things in letters A through D. A through D only. So pause the video, you can do A through D, should be pretty quick, and then come back. Alright, now, our other topic for today then is dividing expressions, algebraic expressions like this one, and actually simplifying them. What you want to do is factor these out. So I've got 4a cubed. So that means that's a times a times a times b over a times b. Now what we're looking for is factors that we can cancel. Well, we can definitely cancel the two a's, and we can cancel those b's. There's nothing to divide the number by, so it's just 4 over 1, which is 4. So we're left with 4a squared times b. And it's over 1, and that would just be 4a squared times b. So we're just factor it out, and then we cancel what we can and multiply the remaining. Let's try another one like that. Here we've got 12. So we've got 3 x's. So x times x times x. And yes, you need to write these out. Not that big a deal. In fact, you can do it a lot faster than I can on the iPad here. Those are z's. Okay. Now we've got 3x times x times z. All right. Let's deal with the numbers here first. We've got 12 divided by 3. Well, that can cancel to a 1, and that cancels to a 4, because 3 goes into both of those. We've got one set of x's. We've got another set of x's, and then we've got a set of z's. All right, now let's look what we're left with on top. We've got 4. We've got an x and a y, and a z. So we've got 4x times y times z. Maybe if I do a cursive z, that'll be better. And I wasn't left with anything again on the bottom, so it's just 4 times x times y times z. All right, here's another one. 10a times a times a times 1b, and then we've got 2 c's. 8a, there's 1a, there's 1b, and there's 2 c's. All right, now let's look at the numbers first. What can you reduce both 10 and 8 by? Well, 2 goes into both of them, so you end up with a 5, and you end up with a 4. That's how many times 2 goes into each one of those, okay? Then we're going to look at the letters. What can we cancel? Well, we've got one set of A's, one set of B's, and we've got 2 sets of C's. All right, and then we figure out that we're left with 5 over 4. And on top, we've got 2 a's left. So that would be a squared. We used the 4, and these all canceled out. So it's 5a squared over 4 would be our answer. Now we're going to do somewhat similar here, finding the square root. Okay, so here's that term I talked about earlier. A monomial is a perfect square if its prime factorization can be separated into 2 identical group of factors. All right, monomial means one term. Remember, terms are separated by plus or minus signs, and this one is there's no plus or minus sign, so there's just one term, monomial. Okay? So let's factor it out. First of all, we're going to look at this number here. Is that a perfect square? Well, it is. You've got 6 times 6, which would equal 36. And then this, to factor out the y, we do y times y. Very similar to what we were doing on the previous slides. Okay, so if I'm finding the square root of this, the square root of 6 times 6 is 6. The square root of y times y is y, and yes, 36y squared is a perfect square, and that is the square root of it. If we were writing it like here, we put a little square root symbol, and it is 6y. Alright, so which of these is a perfect square? One of the first things you can do is just look at the number. Is 8 a perfect square? No, it's not. You can't take a number times itself and get 8, so it can't be A. Alright? Well, B is a possibility because we know we can separate 4 into 2 times 2. Okay, and if you like to group them like that, that would be fine. And then you have x times x, and then you have y. Alright, now that was not a perfect square. We were okay with the 2 times 2. We were okay with the x squared, but there is no way that you can break y up into a square root. So it can't be b. Well, obviously it's c, but let's go ahead and work it out here. We've got 6 times 6. We've got x times x, and we've got y times y times y times y. Alright, so if we take one of the 6's, one of the x's, and 2 of the y's, now I want to show you, they told us it's a perfect square if you've got an identical set of factors. So here we've got a 6, an x. So we've got 2 identical groups, one in red, one in green. So that means that one of those would be the square root. So the square root of that then is 6x y squared, because we broke it up into 2 identical groups that will multiply together to create a perfect square. Alright, and there we go. There's that square root. This is how they would write it. And again, you would do 6, because that's the square root of 36. The square root of x squared is x, and the square root of y to the 4th would be y squared. So there are going to be some problems, something like this also. Alright, so what I would like you to do now is go back into your practice set. Again, it's on page 720, and let's do G through K. So 5 more, not too long, G through K, and then we'll check how you did tomorrow in class.